Hello, my name is Dr. Makita Linear von Quajian, and today we're in our laboratory trying to solve the mystery of quarantine. We have some questions for you today that we need your help. So come on into the lab and let's get to work.
This is Mr. H. So I locked all of my samples in a secure vault, and this vault has a 5-digit PIN number to open. I left myself some clues, but I totally forgot my PIN. So the clues that I left myself was that each or all of my digits added together has a sum of 27. Now, another clue, I said that the first and third digits are the exact same, and the fourth and fifth digits are the exact same. The second digit is the same as the third digit plus half of the third digit. The fourth and fifth digits, they are 1/3 of the second digit. What is my PIN?
What up, my quarantine math people? Back at it again from the lab today. Another awesome question that we're going to have to be thinking through. So let's start off by reviewing the 5 clues Mr. H gave us. First clue was that the sum of all the digits is 27. So when I add them all up together, my answer should be 27. The second clue is that the first and third digits are going to be the same number. The third clue, the fourth and fifth are the same number. Clue number 4 says the second digit is the same as the third, but plus another half of the third digit. And then our final clue is that the fourth and fifth digits are 1/3 of the second digit. Now, that's a lot of information, but again, this is one of these problems you have to think through. So there's 2 ways to do this. You could write an algebra equation and try to use a bunch of different variables, and that's totally fine if you know how to do that. I'm going to show you how to do it even if you don't have any algebra knowledge at all. So the first thing you have to realize is there's only so many digits that we have, right? So all of these are either 1, 2, 3, 4, 5, 6, 7, 8, or 9. Those are the digits that all of our numbers are made up of. I'm going to start then with clue number 5. This is a big hint right here. It says the fourth and fifth digit are 1/3 of the second digit. There's only a few of these numbers that can be 1/3 of a single digit number. The second digit has to be either 1, 2, 3, 5, 6, 7, 8, or 9, right? It can't be a multi-digit number. And if the fourth and fifth digits are 1/3 of the second digit, there's only so many of these that work. Because 9 is 1/3 of 27. Well, the second digit can't be 27 because it's only one digit. 8 is 1/3 of 24. 7 is 1/3 of 21. 6 is 1/3 of 18. 5 is 1/3 of 15. 4 is 1/3 of 12. 3 is 1/3 of 9. So we know that the fourth and fifth digit either have to be 3, 2, or 1. All right? And if we just start there and plug in the numbers, follow the rules to the rest, only one of these is going to work to make it 27. So let's make the fourth and fifth digit 3, okay? So let's just try that out. And if the fourth and fifth digit are 3, that means they were 1/3 of 9, which makes the second digit 9, all right? So now we have the second digit. Now we can go to clue 4. The second digit is the same as the third digit plus another half of the third digit. All right, well, if the third digit can't be 9, so if the third digit is 8, all right, that would be the second digit is 8 plus another 4, which is 12, right? That doesn't make any sense because, again, the third digit has to be one of these. I can't do half of 7 without having a decimal, so that doesn't make any sense. I know the third digit has to be even because I'm going to be adding a half of it to the second digit. So let's skip 7 then. Let's try 6. Okay, well, if the third digit is 6, half of 6 is 3, right? And then 3 plus 6 would make this 9. So that means this meets the rules of clue number 4. All right, so now we have the second, the third, the fourth, and the fifth digit. And it says right here that the first and the third digits are the exact same. So if the third digit is 6, the first digit also has to be 6. Now, I've met all the requirements of my clues except for number 1. We need to double check, because if we are correct, then all the digits should equal 27. And if that isn't the case, then we know the fourth and fifth digit couldn't be 3, so we would cross that out and start this process back over with 2. All right, so let's add them up. 6 plus 9 is 15, plus 6 would be 21, plus 3 would be 24, plus 5 would be 27. So look at that. I got it right in my first one. I didn't really even plan that. And so we know that the 5-digit PIN number is going to be 69633. Again, I know it might be confusing, but what we did is we started with the clue that we could figure out, okay? And then we use that thought process to fill those out and then follow our clues backwards, all right? When you do these types of questions, look for the first clue you can reason through to help you figure it out. I reasoned that, okay, well, the fourth and fifth digits either have to be 1, 2, or 3, because if they're 1/3 of the second digit, these would be the only 3 numbers that work, because if you multiply them by 3 to find the second digit, it still is a single digit number. And then all I did is I just plugged in the first one and I worked through it. I happened to get it right, okay? If you used 2, it wouldn't have added up to 27. If you would have used 1, it wouldn't have added up to 27. So if you don't get it right the first time though, go to the next digit and keep working through. Hopefully you can take this thought process to your next week's Quarantine Math from the Lab. We'd love to have you join us again. Try it out. All of our questions from now on are going to be questions like this, where you have to think through it and maybe try different strategies, maybe plug a number in and check it and see if it works, right? There's going to be different thought processes and problem-solving strategies you're going to have to use if you want to survive the lab and solve the mystery of quarantine.